Recall discrete random variables have probability distributions with a finite or discrete number of outcomes and associated probabilities. But though we know what tends to happen in the long run, we do not know for sure what the very next outcome will be, and this is what makes it a random variable. Sometimes we need to calculate probabilities when one observation will be observed from each of two random variables. In this case, suppose we want to determine the probability that x yields the value 5 and y yields the value 10. It's written this way and is referred to as a joint probability combining outcomes from more than one random variable. Once again, independence is huge. If the outcomes of these two random variables are independent of each other, then the joint probability is simply the product of the individual probabilities. This is like the probability of the intersection of two events. As long as we determine that the events are independent, then it's okay to multiply probabilities. By the way, it's good to know the difference between two events and two random variables. Events are usually categorical, such as students who attend college and students who work part-time. Random variables are always quantitative, like numbers of sales per week or dollars earned from a sale. As long as we determine outcomes from two random variables are independent, then the joint probabilities can be found by multiplying individual probabilities together. In our case, the outcomes of x and y are independent of each other, therefore this joint probability is 0.4 times 0.3. 0.12 is the answer. The joint distribution of x plus y can be found via a tree diagram. Since independence is given, the probabilities can simply be multiplied. Find the probability that x equals 2 and y equals 0, we can just multiply 0.6 times 0.4 and get 0.24. Examples of types of problems include these. Here are the probability distributions of two discrete random variables. If the probability of x equals 2 and y equals 25 equals 1/12, are x and y independent? To determine the answer, multiply the probability of x equals 2 times the probability of y equals 25. It does not equal the joint probability of 1/12, therefore x and y are not independent random variables. Probability of x equals 1 and y equals 3 is 0.49, and x and y are independent. Find the probability that x equals 3. Due to independence, it must be true that the probability of x equals 1 times probability of y equals 3 is equal to 0.49. Probability of y equals 3 must be 0.7 because probabilities in a probability distribution add to 1. Substituting this into our equation helps determine that the probability of x equals 1 is also 0.7. Putting this probability into the probability distribution for x, the probability that x equals 3 must be 0.1, again due to the fact that the sum of probabilities is 1 in any probability distribution.